Welcome to part 2 of the validity lecture. So we left off talking about content validity, which is the most common type, but in all honesty, the second type of validity, which is construct validity, is arguably the most important because a construct is a hypothetical quality. It is that which we use to describe lots of things. Patterns of behavior, for example, good at making new friends, or social, or pretty, or smart, or has high mathematical reasoning ability, or is a good writer. These are all constructs. They're not directly observable. We can think of patterns of behavior that we think are associated with people that have these things. So somebody who's good looking, somebody who is successful, somebody who is pretty, somebody who is talented. All of these are descriptors of something that isn't a particular thing. We can associate it with observable traits or with particular kinds of successes or patterns of behavior, but they're not in and of themselves the construct itself. So simply having a lot of money does not necessarily make one successful, nor does simply having a particular set of characteristics lead to a specific outcome. So when we think about construct validity, what we're really getting at is whether or not the thing that we're measuring, whether it's mathematical ability or it's one's likelihood to succeed in college, whether that construct is accurately and adequately captured by the measurement that we're using. So we use some different kinds of definitions, but the one that is most often referred to is this: the extent to which an assessment measures the construct, for example, reading ability, intelligence, anxiety, that the test purports to measure. So we can collect information in a number of ways, but we usually try to find other types of evidence. As I mentioned earlier, constructs like love or intelligence aren't directly observable. They're only observable through these other behavioral kinds of traits. So one approach is to look at whether or not the items that we think are measuring, for example, spatial intelligence, all respond the same way for similar kinds of subjects. So if the test is meant to measure a single thing, then all of the items should be about equally difficult for people who have similar abilities. We can think about the kinds of mental processes that are required. So if we think that this is about spatial intelligence, then does somebody have to estimate how much area something takes up? Or that there are particular types of geometry or there are particular types of distance estimations that are required? We can also do things like comparing the scores of known groups. So if we're thinking about how well a test may predict future performance, one of the things that we can do is to look at past performance, and we use that to then apply to new groups that come along. So for example, correlational studies that look at things like the ability of the SAT to predict first and second year achievement in post-secondary education and college, that's done by looking at how people who have finished the first 2 years of college, how well did they do? What was their GPA? And then we associate or correlate that with their overall score on the SAT. We can also compare the scores before and after a treatment. So if we think that we're going to really have a positive effect on children's writing ability, then we can test the scores for writing beforehand and then afterwards. But of course, that's all subject to how good is our assessment in actually measuring writing ability. And so finally, we can correlate scores with other constructs. And do they do well or do they do poorly? If we think that spatial reasoning and mathematical computation should be correlated skills, then we would expect tasks that ask for those things to be highly related. If we thought that perhaps they were not related, we would expect them to be poorly correlated. So if we thought that spatial reasoning was really different than mathematical computation, then we should find that they're relatively unrelated. Some other things that I think are important to note about construct validity is that it's usually assessed after the fact. So we look at past performance, as I mentioned before with the SAT, and we think about how this might apply to future groups. It usually requires some kinds of test scores or performance outcomes, and it's a complex, logical, and extended process that most teachers are not going to engage in. Nevertheless, it's very important that test publishers engage in this process so that we can establish the longer-term validity of an assessment. So even though this isn't something that you may do as a teacher, it's the foundation upon which all of the large-scale assessments that we give in schools are derived. So I want to just give an example about construct-related evidence. And so here's a chance for you to jot down something to yourself. And I may open up a new discussion thread just to share your answers to this. This isn't really one of your official discussions, but it's illustrative of how complex constructs are, and yet how well we're able to, as human beings, reduce them to something that's comprehensible. So, what is love? What is the operational definition of love? What are the characteristics of love? And are those things that we describe all-inclusive? So take a moment right now, you can pause the video, and jot down a one-sentence definition for what you think love is. 10, 15 words, and write that down, and then on the discussion board you can go ahead and contribute your suggestion. So when I do this in class, I note that as many people that there are in the class, I have as many definitions for what love is. Love is passion, is sometimes what some folks will say. Love is an enduring commitment to another person. Others will chime in. And again, as many people as I have are as many definitions as are given. Calvin and Hobbes had a little bit different interpretation of love. Susie says, "Hey Calvin, are we near a slaughterhouse or did you forget your deodorant?" "Drop dead, Susie. You're so ugly I hear your mom puts a bag over your head before she kisses you goodnight." He says, "It's shameless the way we flirt." He then goes on to ask Hobbes, he says, "What is it like to fall in love?" "Well, say the object of your affection walks by." "Yeah." "First your heart falls into your stomach and splashes your innards. All the moisture makes you sweat profusely. This condensation shorts the circuits to your brain and you get all woozy. And when your brain burns out altogether, your mouth disengages and you babble like a Cretan until she leaves." That's love? Medically speaking, he says. That happened to me once, but I figured it was cooties. So another type of evidence for validity is criterion evidence. And a criterion is some kind of a valued performance or outcome. So the earlier example that I gave about the SAT, which is success, in that case was success in college, is the outcome criterion. It's the thing that we say is the valued performance. So other ones might be that the child scores high on a standardized test in math and later does very well in an algebra class. So that we would use that algebra test or that math test to be a good predictor of whether or not they're likely to be successful in a class. So a criterion reference or criterion validity is really the extent to which the validity of our assessment is demonstrated by some usually later performance by a child or by an individual that then demonstrates that our earlier assessment was predictive of something that we value as an outcome. So a definition is the extent to which a test scores correlate with a valued performance outside the test. So there can be concurrent correlations. So how does the student's NAEP performance, which is the National Assessment of Educational Progress in math, compare with their grades? Or it could be a predictive correlation. And I gave this example already. How well does the SAT predict performance in college? How about high school GPA? How well does high school GPA predict performance in college? And what's interesting is in both cases they're about the same. So as a side note, SAT is about equally predictive as one's entire undergraduate GPA, or excuse me, high school GPA. So some important points. This always requires test scores, some kind of relationship between an assessment and an outcome. It's quantified. We're literally computing a correlation coefficient. And it has to be interpreted cautiously because there are a lot of other factors that can raise or lower these validity coefficients. So, for example, we might note that high SAT scores are associated with solid performance in the first 2 years of school. We might also note that high SAT scores tend to be related to students completing very high-level courses in high school. And so the two things really are what we call this kind of multicollinearity. That is, that we have multiple things that are associated with an outcome really prevent us from being able to accurately determine what it was that made that child be successful in college or made that child be successful in the algebra class. So we have to be careful that just because there's a relationship between a test score and an outcome, that test score, although it may be predictive, certainly is not the cause of that outcome. One of the other problems with this is that it can create this issue where we have expectancy tables. So if we know, for example, that being black and being successful in post-secondary education have a very poor relationship, or being Asian and having a very successful outcome in post-secondary education, we could use that to construct an expectancy table, which is that if we know that somebody has a risk factor, they're female or they're male, or they have a disability, or they're a particular race, then we could use that information to sort of systematically exclude folks from different kinds of opportunities. These are risk ratios, and although this isn't a class on that kind of those kinds of statistics, risk ratios really are multiplying the factor by which we would expect someone to be successful or unsuccessful. The problem is that risk ratios, or these expectancy tables, really aren't useful in thinking about individuals. They're useful for thinking about how groups will do. But when they're applied to an individual person, there's a real issue of equity and fairness in terms of the kind of access that individuals could have. Colleges could be much safer by saying we're going to exclude these ethnic minorities because we don't think that they'll be as successful. Or we could exclude women, or we could exclude men from particular programs because we know they have a history of being less successful. But that ignores the fact that individual variation is more important than somebody's group membership. So expectancy tables are one of the kind of more negative outcomes of criterion-related evidence as it applies to validity. One of the things that I've mentioned a couple of times here is this idea of correlation. And just as a quick review, correlation is simply a statistic that indicates the degree of relationship between any two sets of scores. So, for example, we could correlate between height and weight. And they're not perfectly correlated, but they are strong and positive. A validity coefficient is used when calculating the criterion-related evidence of validity. So, for example, that SAT performance versus the first 2 years GPA in college. A reliability coefficient, however, is used when calculating the reliability of test scores. So how high did someone score on the first test versus how high did they score on the second test? We'll look at correlations more in depth when we discuss descriptive statistics, and I have a whole piece actually in the online course on correlations. So if you're not sure about how positive and negative correlations work, this is a good time to take a look at that and make sure that you understand that before you get too far into the validity and reliability discussion. The final part of the validity discussion is really around consequential validity. And it's not really a validity issue in and of itself, but it is an important consideration when we think about what happens as a result of our assessments. Consequential validity is simply the effect that your assessment or assessments had or have that is important to you and is important to other people that are involved. There are a lot of consequences that are associated with assessments. One consequence is that we might have students that study harder as a result of knowing that they'll be tested. Another consequence is that we have students that may experience test anxiety as a result of knowing that an assessment is coming up. So we have a number of different kinds of consequences that can happen, and this is really directly tied to one of the discussion topics that we have posted, and that ties to this idea of whether or not large-scale assessment and assessment in general is more harmful than it is beneficial. And I think depending on your perspective and depending on how you look at the effect of this, one could come down on either side of the conversation. And of course, it's not as simple as saying this is one or the other. So other kinds of consequences that I might lay out, for example, in large-scale assessment, the passage of No Child Left Behind narrowed the number of subject areas that were tested each year in many states. And as a result, it may have had the effect of narrowing the curriculum and certainly emphasizing certain aspects of the curriculum over others. We saw a heightened focus on early literacy and a heightened focus on early math skills. So it's hard to argue with the benefit of those, but at times perhaps those came at the exclusion of other kinds of fine arts or performing arts. So consequences, in my use of the word, are both positive and negative. So when we think about consequential validity, we need to consider that any assessment that we provide has a set of consequences, both the benefits that we intended, but also potential drawbacks that we didn't. I want to close this section on validity with a quote from Margaret Wheatley. And she said, "Every active measurement loses more information than it gains." And I would argue that this is a fair warning to us that in assessment, we have to be very careful that we're doing assessments that are really necessary for us to understand what it is that we're looking for. And the issue of validity is the core of good assessment. We don't need to be spending time doing tests unnecessarily, nor do we want to have students engaged in pointless multiple choice assessments of knowledge that have very little meaning or bearing on their long-lasting kinds of outcomes in school. At the same time, there is the need to certify that children understand certain concepts and in fact have particular pieces of knowledge. My closing point is that whatever type of assessment we engage in, we need to ensure that it's valid, that it is aligned to our learning objectives, and that we use it judiciously and conservatively.